Google Earth is designed to show the world exactly as it is. Mountains, rivers, cities, deserts, all captured from space and stitched together into a single digital planet. But sometimes, while exploring, you come across places that don't feel real at all. Perfect shapes where chaos should exist. Patterns that look copied and pasted. Landscapes that seem more like corrupted textures than real ground. In today's video, we're looking at 15 locations on Google Earth that feel like glitches in the Matrix. These aren't editing mistakes, loading errors, or fake images. Every single one exists in the real world, and that's what makes them unsettling. Number 15. Desert Breath, Egypt. High above Egypt's eastern desert near the Red Sea coast, an enormous spiral suddenly appears in the sand. From a satellite view, it looks artificial, almost digital, like a procedural pattern generated by software. Many people assume Google Earth failed to render the terrain correctly here. But this isn't a glitch. This is Desert Breath, a massive land art installation created in 1997 by the DST art team. It covers nearly 100,000 square meters and consists of two interlocking spirals made from excavated sand cones and depressions. At the center sits a circular basin that once held water, now dried by evaporation. What makes Desert Breath so convincing as a glitch is the contrast. The surrounding desert is chaotic and irregular, while the spirals are smooth, precise, and geometric. There are no nearby cities, no roads, no signs explaining why it exists. When you stumble upon it in Google Earth, it looks like corrupted terrain data. On the ground, the structure feels abstract and disorienting. From above, the geometry snaps into focus. Every ridge and curve you see on Google Earth corresponds exactly to physical Earth moved by heavy machinery. No illusion, no rendering error, just human geometry clashing violently with nature. Number 14. Center Pivot, Irrigation Circles, Saudi Arabia. If you scan across the deserts of northern Saudi Arabia, something strange happens. Endless sand suddenly gives way to perfect green circles, appearing out of nowhere. Dozens of them, sometimes hundreds. To first-time viewers, they look like repeated textures stamped across the desert, a classic map glitch. In reality, these are center pivot irrigation fields. Long sprinkler arms rotate around a central well, watering crops in a precise circular radius. From the ground, the systems look industrial. From space, the uniformity feels unreal. The contrast is extreme. Barren desert next to bright green geometry. Some circles appear incomplete, faded, or clipped where water extraction was reduced. These broken arcs amplify the illusion of corrupted imagery. You'll find similar patterns in the United States, Libya, and Australia, but Saudi Arabia's examples stand out because of their isolation and density. They don't look like farms. They look like something the planet wasn't supposed to display. Number 13. The Sea of Plastic, Spain. Zoom into southeastern Spain and parts of the coastline turn blinding white. Instead of hills or towns, the landscape looks like a map tile that never finished loading. This is the Sea of Plastic near Almeria, one of the largest concentrations of plastic-covered greenhouses on Earth. From above, the reflective plastic roofs bounce sunlight so intensely that satellite sensors record them as bright white sheets. Rather than one smooth surface, the area forms a quilt of rectangles at slightly different angles and brightness levels. It feels less like land and more like a texture file. Using Google Earth's time-lapse feature makes it even stranger. The white area slowly expands over decades, creeping outward like a spreading stain. Nothing digital is happening, it's simply agricultural growth, scaled up until it becomes visible from space. Number 12. Salar de Uyuni's Polygon Grid, Bolivia. Salar de Uyuni is the world's largest salt flat, stretching over 10,000 square kilometers. On Google Earth, it looks impossibly flat, like the planet has been replaced by a tiled surface. During dry periods, the salt crust fractures into polygonal patterns as it contracts. From orbit, these cracks form a grid that stretches endlessly in all directions. It looks engineered. It isn't. The flatness is so extreme that space agencies use Salar de Uyuni to calibrate satellites. During the wet season, A thin layer of water turns the surface into a mirror, reflecting the sky so perfectly that objects appear to float. When dry and wet zones meet, sharp boundaries appear, like mismatched tiles in a map. The brain expects messiness. Uyuni delivers precision. Number 11. The Gobi Desert Grid, China. In remote parts of China's Gobi Desert, satellite imagery reveals enormous geometric grids carved into the land. Straight lines, sharp corners, repeating blocks. They look like corrupted textures or an unfinished 3D model. These patterns are real. They're human-made markings linked to geological surveying and satellite calibration. Shallow trenches and contrasting materials were laid out so they'd be visible from the air. What makes them disturbing is scale. Individual lines stretch hundreds of meters. Entire grids span kilometers. There are no nearby cities or roads, just geometry sitting alone in the desert. Different satellite passes taken years apart show the same patterns. Some fade, others appear suddenly. It mimics a loading error, but it's real change over time. Number 10. Lena River Sandbanks, Siberia. The Lena River is over 4,400 kilometers long, and in northern Siberia it spreads into vast braided channels. From above, the river fractures into repeating strands, islands, and sharp-edged sandbanks. At certain zoom levels, it looks like duplicated terrain tiles. Seasonal flooding, ice breakup, and sediment movement constantly reshape the river. Google Earth captures single moments, frozen snapshots of a system mid-transformation. Adjacent image tiles can show different water levels, creating seams that resemble stitching errors. Nothing artificial is happening here. Nature is simply operating at a scale large enough to confuse our pattern-hungry brains. Number 9. Bingham Canyon Mine, USA. From space, Bingham Canyon Mine looks like a massive spiral carved into the earth. Perfectly stepped terraces descend into a circular void. It feels like a digital vortex. This is one of the largest open-pit mines on the planet, over 4 kilometers wide and 1,200 meters deep. The terraces, called benches, are engineered for stability and access. Roads spiral downward, reinforcing the pattern. In 2013, a landslide here moved over 65 million cubic meters of material. Detected by seismic sensors, the mine is measured, mapped, and undeniably real. It only feels impossible because of its scale. Number 8. The Badlands Guardian, Canada. In southeastern Alberta, a human face stares back from Google Earth. Eyes, nose, lips, even what looks like headphones. This is the Badlands Guardian, a natural formation created by erosion. The illusion only works from above. On the ground, it's just gullies and ridges. A nearby road and oil well pad happen to sit exactly where the ear appears, strengthening the illusion. Older aerial photos confirm the land existed long before the infrastructure. It's pure pareidolia, the brain forcing meaning onto randomness. Number 7. Netherlands Tulip Field Patchwork. At certain times of the year, parts of the Netherlands don't look like farmland at all. On Google Earth, the land suddenly turns into sharp blocks of intense color. Deep reds, bright yellows, purples, and whites laid out in long, perfectly straight rectangles. To someone scrolling casually, it can look like a corrupted color layer or a texture test accidentally left on the map. What you're actually seeing are large-scale tulip fields in full bloom. The Netherlands is one of the world's biggest producers of flower bulbs, and these crops are planted in dense, uniform rows across extremely flat land, much of it reclaimed from the sea. Different tulip varieties bloom at slightly different times, and when satellite imagery captures the peak moment, entire regions explode into color at once. From the ground, each field feels normal. From several kilometers up, hundreds of adjacent plots merge into a single mosaic. Satellite sensors also amplify vegetation differences, making the colors appear even more saturated than they do to the naked eye. Nothing here is artificial or enhanced. It's just agriculture, timing, and geometry combining into something that feels unreal from space. Number 6. The Aral Sea Retreat. On Google Earth, the Aral Sea region looks broken. Coastlines with no water, river channels that end abruptly, pale seabed textures stitched next to darker land. It feels like the map failed to update properly. In reality, you're seeing one of the most dramatic environmental transformations ever recorded. Until the mid-20th century, the Aral Sea was among the largest inland seas on Earth. Starting in the 1960s, its feeder rivers were diverted for irrigation, and the sea began to shrink rapidly. Google Earth compresses decades of change into a single surface. Adjacent imagery tiles may represent different years, water in one, dry land in another. The exposed seabed reflects light differently, creating sharp visual seams. Rusting ships stranded far from shore look like misplaced objects dropped onto the map. Nothing here is a glitch. It's history layered on top of itself, viewed all at once. Number 5. Lake Hillier's pink surface. Off the southern coast of Western Australia lies a lake that looks like it was colored incorrectly. On Google Earth, Lake Hillier appears as a solid, uniform pink shape sharply separated from the deep blue ocean beside it. There's almost no gradient, no transition, just pink next to blue. The color is completely real. Lake Hillier's hue comes from microorganisms that thrive in extremely salty conditions, producing pigments that tint the water. Unlike many colored lakes, this one stays pink across seasons and water levels. Even samples taken from the lake remain pink outside it. From space, that consistency feels unnatural. Natural lakes usually show variation, sediment patterns, or murky edges. Here, the clean boundary looks like a graphic overlay. Google Earth doesn't exaggerate the color. It simply captures something biology created that looks more digital than natural. Number 4. Khaluts of Dasht-e-Lut, Iran. In eastern Iran's Dasht-e-Lut desert, the land looks carved into rigid rows of massive rectangular ridges. From above, these formations resemble a ruined city grid or a repeated terrain pattern copied across the desert. These structures are called khaluts, and they were shaped by wind erosion over immense periods of time. Strong, persistent winds stripped away softer sediments while leaving harder material behind as steep-sided ridges aligned with the prevailing wind direction. From the ground, the terrain feels chaotic and maze-like. From space, the alignment snaps into order. High sun angles exaggerate shadows, making the edges look sharper and more artificial. There's no illusion, no color trick, just erosion producing geometry that clashes with how we expect nature to behave. Number 3. The Nazca Lines, Peru. On Google Earth, long straight lines stretch across the Peruvian desert for kilometers, intersected by enormous animal and geometric figures. They look like overlays accidentally left visible on the terrain. These are the Nazca Lines, created between roughly 500 BCE and 500 CE by removing dark surface stones to expose lighter soil underneath. The extreme dryness of the region preserved them for centuries. What makes them feel glitch-like is scale and perspective. At certain zoom levels, the lines appear bold and intentional while surrounding terrain details fade away. Zoom in further, and the shapes dissolve into ordinary stones. That sudden change feels like a rendering shift, but it's just resolution limits. Google Earth didn't invent the patterns. It finally made them readable. Number 2. Racetrack Playa, California. Racetrack Playa looks unfinished from space, a flat, pale surface crossed by thin, dark lines that change direction without logic. These lines don't follow slopes or curves you'd expect from erosion. They look like motion frozen into the terrain. The marks are trails left by sailing stones, rocks that move across the playa under rare conditions. Thin sheets of ice form during cold nights, then break and slide when temperatures rise. Light winds push the ice, slowly nudging the rocks along. Google Earth shows the result, not the movement. Without seeing the ice or wind, the tracks feel impossible. The physics make sense, the perspective doesn't. Number 1. Yamal Peninsula Gas Craters, Siberia. In northern Siberia, large circular holes appear in the tundra between Google Earth updates. Sharp rims, dark interiors, no gradual transition. It looks like the terrain failed to load. These craters formed when methane gas built up beneath thawing permafrost and exploded through the surface. The events were sudden and violent, ejecting soil and ice outward and leaving deep holes behind. Some craters later filled with water, becoming round lakes. On satellite imagery, a dark hole becomes a blue circle between frames, making it feel like the map is cycling versions. It isn't. The land itself changed. Google Earth didn't glitch. The planet updated in real time. What all of these places have in common isn't mystery, aliens, or secret codes hidden in satellite imagery. It's something simpler and more uncomfortable. Our brains expect nature to be messy. When we see perfect circles in a desert, grids carved into emptiness, colors that don't blend, or geometry that feels intentional, we assume something went wrong. A glitch, a rendering error, a mistake in the data. But Google Earth isn't creating these patterns. It's revealing them. Satellite imagery strips away context, sound, motion, time, scale, and leaves us with pure shape and color. And when real processes operate on massive scales or under extreme conditions, they can produce results that feel more digital than natural. Sometimes it's human engineering colliding with the environment. Sometimes it's geology following simple rules over enormous time spans. And sometimes it's the planet itself changing between snapshots. The map didn't fail to load. We're just seeing Earth from an angle our minds weren't built for.